Now let's talk about the one kinds of fog, as we call it radiation fog. So radiation and conduction are the primary mean for cooling nighttime air near the ground. Fog produced by Earth radiational cooling is called radiational fog, or we can say ground fog. It forms based on clear night when a shallow layer of moist air near the ground is overlain by the dry air. Because the moist layer is shallow, it does not absorb much of the Earth's outgoing infrared radiation. The ground, therefore, cools rapidly, and so does the air directly above it cools rapidly too, and the surface inversion forms. With this surface inversion, cooler air at the surface and warm air just above. The moist layer, lower layer, that chilled rapidly by cold ground, quickly becomes saturated, and fog forms. The longer the night, the longer the time of cooling, and the greater the likelihood of the fog will form. Therefore, radiation fog are most common over the land in late fall and winter. Another factor that promoting the formation of radiation fog is a light breeze of less than 5 knots of the wind. Although radiation fog may form in calm air, slight air movement bring more to the moist air into the direct contact with the cold ground, and this transfer of heat occurs more rapidly. A strong breeze wind tend to prevent radiation fog from forming by mixing the air near the surface with the drier air directly above it. The ingredient of clear sky and light wind are associated with large high pressure area like anticyclone. Consequently, during the winter, when an anticyclone becomes stagnant over a area, radiation fog may form on many consecutive days for a long time. Due to the cold, heavy air drain downhill and collect in valley bottom, we normally see radiation fog forming in low-lying areas. Radiation fog is frequently, that's why I called it the valley fog. The cold air and the high moisture content in the river valley makes them susceptible to radiation fog. Since radiation fog normally form in the lower land, hill may be clear all the day, but the adjacent valley will be fogged in. So radiation fog form upward from the ground as the night progresses and are usually deepest around the sunrise. However, the fog may occasionally form after sunrise, especially when evaporation and mixing take place near the surface. This usually occurs at the end of a clear, calm night as radiational cooling brings the air temperature close to the dew point in a rather shallow layer above the ground. At the surface, the air becomes saturated, forming a thick blanket of dew on the grass. At daybreak, the sun's rays evaporate the dew and add water vapor into the air. A light breeze then stirred the moist air with the drier air directly above it and caused the saturation condition to form in a shallow layer near the ground. So this is how radiational fog actually produce. Let's go with some example of the different radiational fog. If the fog is thick with little sunlight penetrating it, and there is a little mixing along the outside edge, the fog may not dissipate. This is often the case in the Central Valley area of California during late fall and winter. A fog, for instance, over 500 meter thick settle between two mountain ranges, while a strong inversion normally keeps the warmer air above the top of the fog. This often called Tule fog, after a types of plants commonly found in the Central Valley where it's formed during the day. Much of the daylight from the lower winter sun reflect off the ground of the top, of the tube fog, allow only a small amount of sunlight to penetrate the fog and warm the ground. As the air warms from the below, the fog dissipates upward from the surface in a rather shallow layer less than 150 meter. And it creates the illusion that the fog is lifting, actually not, actually the evaporation happening. And because of the fog no longer touches the ground at that situation and a strong inversion exists above it, we call it high inversion fog. So we understand the radiational fog and the classification of this radiational fog. To understand, it's mostly happen because the cooling of radiation of the ground infrared radiation and cools down at night, and mostly it would be more visible when the night is calm and little wind, but night is mostly calm.